started. Welcome to the second session this morning of the OSGI community event today. My name is John Ehrig, and I'm the Executive Director of the OSGI Alliance. I recognize some OSGI Alliance members out there, and thank you very much for your continued support. But if you're not a member, I'd like you to consider joining and doing a little bit of research into what we're all about. I think we're doing some really great work, and appreciate if you'd go to osgi.org and take a look and see if you could consider joining our group. We could certainly use the help. So, good morning and welcome, and thank you for coming this morning. It's with great pleasure that I introduce today our speaker, Andre Botaro, who is going to be speaking on end-to-end standard oneM2M infrastructure for the smartphone, as you can see right there on the slide. Andre has been working on research projects in various IoT environments, especially the smart home, for the Orange Labs since 2003. He is presently in charge of the Digital Home Research Program of the group, which shows great challenges in the openness to third-party applications in home gateways and devices. His work addresses robustness, resource management, and service dynamic composition on component frameworks. He's authored international publications, patents, actions, and standardization to organizations including the OSGI Alliance, UPnP Forum, Broadband Forum, Home Gateway Initiative, and ISO IBC. He holds a PhD from Grenoble University. And welcome, Andre. Thank you.
Thank you very much. So it's always a pleasure to be here with the yearly community event. So yeah, as John said, I've been working for a moment now on the openness, on an open infrastructure for an ecosystem of players in the smart home area, and that was mainly focused on the box software architecture, the box that is in the home for the smart home. And today I will introduce a new work on an infrastructure that is focused here on the balance between what we could deploy in the cloud and in the box in a homogeneous architecture. And for this architecture, we have, with the team in the Orange Labs, we have worked with the integration of oneM2M standards that has just been released this year on the OSGI framework. And we use for that Eclipse oneM2M project that we integrated with the Open the Box project that we maintained with the Orange Labs. So my vision of the smart home is a home that is open to any application, any thing, a home that is assisting the user in their everyday life in the most natural manner. And this vision is, of course, shared somehow with different labs, especially in the telecom operators companies. And this is the result of several technical and scientific trends that were called pervasive computing, or ubiquitous computing, ambient intelligence, and so on. And in this area, we could recall, a very famous article from Mark Weiser, who was a very good visionary in the pervasive computing area. So he has launched this trend on pervasive computing with the assumption that the processing power and the communication capabilities of things will be exponentially increasing, and they could be deployed in a lot of things in a various environment of our everyday life. So that's the case for the home, and he also showed in this article in 1990 that for those systems to be acceptable and for the services of the system to be attractive for the users, all this processing power and communication capabilities have to be pervasive and invade the home in the most invisible manner. So maybe today you have a home that could look like this, And tomorrow, if really all these capabilities are deployed in the home in an invisible manner, tomorrow you will have a home that will look the same, with the same shape, but then all the things will become smart, and the user interfaces will become the home itself and the environment itself. And this was the very idea of Mark Weiser at this moment. And today, all these trends have come into this IoT ID, the Internet of Things, that is just beginning in the industry. So just focus on the smart home market. So the smart home market is today still in a status of niche markets, with usually we have 7 categories. We could have a little more or less categories. So we often speak about security, energy, comfort, health, wellness, multimedia, and games at home. And with the emergence of new products that are connected, more connected and smart, easy to install and wireless, then we see a new world of applications coming. And the home will really become smart if we have a system that cross the silos of these application domains, and that cross the data and to offer services that goes beyond those application domains. So for this picture to come true, there is a technical opportunity that is now exploited by some pioneer companies. That is the use of a telecom infrastructure that we have today, and we enlarge and we open that to many players of a new ecosystem. And in this new ecosystem, we have several roles. The players have several roles to play, and I have described here 5 roles that are key in this system. So the first one is, of course, the role of the user. So the user will expect this home open to any service, assisting them in their everyday life. There are these roles that are very important of the service provider and the device provider that are separated here in order to unleash all the combinations that we could have between services and things that are shared in the home. So the service provider and the device providers will want to sell services on the largest market, meaning that a market that is international, with a deployment that is over the top. They want to deploy services and devices without any entry barriers. That means that they don't want, I think, in this ecosystem, there's an opportunity to share a box and an infrastructure, and not to pay the cost for every service provider and device provider for a new box. And of course, all these partners will look for a system that with APIs and software skills that are very well spread and common, in order to make applications and things developed with very easily with a low cost. And both of these actors will want to benefit from infrastructure services provided by another player that we can call the smart home operator. So the smart home operator is the one that sells the services of this infrastructure, meaning the device management, the management of devices with neutral services. As devices and services will be brought by different players, this operator will have to certify those services that could be deployed or connected to the system, and will have to label the devices that could be connected to the system. And of course, the smart home operator will deploy the infrastructure in any home on a global footprint. So it means that in most cases, it will be over the top. And then there is a key player, who is the software developer. And here we could make a comparison with the smartphone area, where the software community is really a key asset of the players that have won the market. So here, of course, the software developer will look for the easiest, the richest standard software development kit to develop their applications and their they are connectors to various things. So what is this system that could be shared in the home by various players? So this is a system that comes from the traditional home network that connects today your multimedia devices in the home to a router. And in a second step, we see already today some add-ons that connect to the router some new low-rate network protocols with new radio chips, new radio sensor networks. We have also other systems that shows cloud-to-device communication between smart devices and service platforms, and they directly communicate through a router that has only simple router capabilities. And for those types of all those systems and to cover all the type of applications of the smart home, we need that applications are partly deployed in the cloud and partly deployed in the box. So that depends on the technical requirements of every application. And of course, these applications will need the connection to things that are either on high rate protocols on the home network of from today that don't need new radio chip on the router or on another box, and they also will want to be connected to things that are needing low power radio protocols, and that means new radio chips in a router or another box. So there are various technical challenges to open such a system to a very large community of developers, and we see with some examples today that there are some consortiums and some alliances that make progress on this vision. And today I want to focus on two main challenges. We could say three challenges. The first one will be a focus on how to have a device abstraction layer that is common in the cloud and in the box, and I will show how we made it with a concrete project and concrete technologies in this presentation. And the second one is how to manage the user access rights and the access rights from applications to access other applications or devices in the home. And the third challenge is more how we made it. We made it with the constraint of using standards, and we used in this prototype the last release of the first release of oneM2M. So I will introduce you what is the oneM2M organization and those standards, and of course OSGI, and that's why I present that today. So oneM2M, according to Omar Eloumi, who is the technical plenary chair of oneM2M, is a software layer that is language agnostic, that sits between M2M applications and transport layers. And oneM2M has specified RESTful APIs for applications to connect in the cloud, or applications to connect to use APIs on a gateway or directly on a device. So it allows for distributed intelligence in this architecture, and they use RESTful compatible technologies. If you don't know oneM2M, that is a very big consortium, or more a standard body that has been created by 8 other standard bodies around the world, and now more than 200 members contribute to oneM2M. So the remaining of this presentation is twofold. So I have first focus on how to manage a device abstraction layer that is both deployed in the cloud and in the box, and that is synchronized thanks to oneM2M specifications. And the second focus will be on the management of user access rights in this infrastructure. So we see with several reference architecture, we could name the one of the Home Gateway Initiative, we could name the one of oneM2M and other visions. That there are mostly three levels to represent local home devices and applications. So in most of our infrastructure, we have at least the first level where we have drivers that are specific to radio technologies, and where we send some orders that are with specific commands and specific protocols related to the mentioned technologies here. At the second level, we have an abstraction that is technology agnostic and that enables applications to send orders with methods and parameters that are agnostic to technologies. And then at a third level, we could have higher level applications that groups devices or that make some scenarios above devices. And above this application layer, we could send higher level commands like how to decrease the overall energy consumption of the home. So that makes three layers that could be locally used or remotely called by a cloud service platform. And we need, of course, bridges towards the cloud service platform. Then if we implement that with OSGI technology, we have several specifications that show the way to go. So we have at least two examples of base drivers, like UPnP device service specification for a long time now. And we have also standardized the N-Ocean device service specification in the residential expert group, and we hope that we will have the ZigBee device service specification in the months to come. So, and we could, of course, in the IoT expert group, extend this list of APIs. At the second level, I use the term refining driver to describe the adapters that dynamically represent the devices coming from the base drivers and that are registered in the OSGI service registry. And refining drivers register services that are agnostic to technologies, or sometimes they remain agnostic, but they raise the level of abstraction for the developers. So here, with discovery base drivers that dynamically represent devices as service proxies registered in the registry, we have technology-specific device communication, but with a Java model, Java object model. Then at the second layer, we could have such a command that is very friendly to developers with objects and methods that are really specific to devices and to a business. And then we could have above that applications or generic rule engines that use that and expose also other APIs at another level to have higher level orders coming from local applications or from the cloud. And from the cloud, of course, to bridge the box with the cloud, we need connectors. So in the OSGI specifications, we have at least the TR69 connector that has been implemented. And we have also, we could have, if we are active in the oneM2M, in the IoT expert group, we could have maybe in the years to come a connector for other technologies like oneM2M. So here I have a slide to introduce how we relate the M2M model with the OSGI technology. So the oneM2M standards have standardized the representation of applications, local applications, and devices in the home and various IoT environments, and they have a tree data model that we see here, and that is expanded here for devices that show how to represent those devices and applications. So let's begin with devices. So devices for oneM2M are logically described with several levels, and we could have, I think they have made a comparison with Zigbee or other very well-known specifications that have all these levels. So here, in an entire working proxy unit, you could have many, several networks that are represented. So one network per technology. In a network, you have several devices. In a device, you have often one or more logical units that have interfaces. And then an interface is a set of commands, if we recall the vocabulary of Zigbee, and a set of data fields or attributes. And so that's the fact for devices. And for applications now, to represent applications, so that is, we have this concept of applications that are on the devices and also in the box or in the environment in oneM2M. And to do the link with OSGI, we need in the OSGI technology an entity that is representing an application. And that's where today there is no used specification today from the OSGI Alliance, but we see that various commercial products have modeled what is an application above OSGI. And in this project here, an application is a set of bundles that is using the framework that is provided by the smart home operator. So the smart home operator framework is made of an OSGI framework with several technical bundles and base drivers, and that is providing APIs that can be used by various tenants, various players above that with their applications. Then, just to detail what is the architecture of our prototype in the box to directly control the devices from the cloud. So we have the first layer with base drivers. Then we have a layer of refining drivers that refine the abstractions into only one abstraction that is mapped into the oneM2M abstraction. So we can call here oneM2M applications that have interfaces, methods, and data fields. Of course, we could discuss the fact that maybe here we see that even in this abstraction model, we have mapped technology-specific parameters, and maybe we could have a third layer in between. We could use, for instance, the OSGI device abstraction layer to have a model that is completely agnostic for the adaptation of oneM2M. But the fact is that we have made this thing because oneM2M has already made some progress into mapping those specific technologies into their model. So that was straightforward to do this implementation that way. To call applications from the cloud, we have specified in our prototype the way to expose services remotely to the oneM2M connector towards the cloud. So that is depicted here when the M2M connector could discover all the M2M application services, so the applications that are exposed publicly for the cloud or other local applications, and that are described with the oneM2M abstraction model, with applications, interfaces, methods, data fields. So now let's focus on the second part, the second challenge, which is the management of access rights from the users and the applications to access devices and other applications. So here I give a view of the end-to-end architecture here, with the box layer and the cloud layer. And we see here that in the cloud, applications are connected through RESTful APIs in the oneM2M model. And in the box, there are local applications that directly use the Java OSGI APIs that I have represented in the previous slides. Of course, you could say that we could also embed OSGI applications in the cloud layer. So that could be also added to the slide. I didn't make the thing. What is interesting is that thanks to oneM2M capabilities, they have specified the way to synchronize the abstraction layer with the data tree model between the cloud and the box. So the device abstraction and the applications, the inventory of applications are shared in a similar way in the cloud and in the box. And then to implement the management of access rights, we have some filters at some levels. So first filter on the calls to RESTful APIs in the cloud, with applications in the cloud that has only the visibility of the parts of the tree data model that have been configured as accessible for the partners that access those APIs. So that means that the browsing in the tree and the tree data model is managed with access right configuration, and that is specified in the oneM2M model. And in the box, the filter is made above the service registry with, thanks to OSGI conditional permission admin and Java permissions that implement the access right, the visibility on devices and applications in the service registry. So if you have an access right towards the device, you can discover that in the OSGI service registry. And if you don't have, if your application doesn't have the access right towards the device or another application, it doesn't see the service, the expected service in the registry. So we have a filter on the RESTful APIs with filters on the service registry for the communication through services between applications. And we have also the same approach here towards the use of devices that are represented as services in the service registry. Just a snapshot of a very advanced user interface for an administrator in the home if he wants to configure himself the access rights from a person of the family, here Leah, who has access to part of the human lights applications here, for instance, and to some of the devices in the home, and here we see a Zigbee plug and a U-lamp. And of course, there is a part of access rights to the higher level management features, and we have depicted that in this snapshot. We could see also that we could manage access rights between partners and between partner applications. So of course, the operator will configure first the access rights between applications, and of course, the partners would have given to the smart home operator their expected configuration, because of course every partner has an opinion of who can access their application. And so the operator would have configured the access rights first and the Java permissions, and then there could remain some options for an administrator to configure some of them. Okay, so here I just want to say that the architecture is implemented with several projects that are public. So we have, from the Orange Labs, we have published at least binary software to make a tutorial and some use cases above Open-the-Box model. From Open-the-Box, we used in this prototype the application model that is explained on openthebox.org. We have also used something that is not already published on the website, but we will publish it in the months to come. So the access right management model. And then we also have on this website the Zigbee and U OSGI based drivers, at least as binary drivers. binary bundles. Then we collaborated with Eclipse oneM2M team to integrate their oneM2M bundles, because oneM2M is implemented already into OSGI bundles in the embedded environment and in the cloud. And we used, for the moment, the implementation that is in 0.8 version, so that means the HCM2M implementation. And if you know the ecosystem, you know that HCM2M has contributed their specifications to oneM2M, so when we will move to a full oneM2M system, we will have mostly the same APIs and the same architecture. Then we use, of course, the OSGI and Ocean base driver that we have contributed some months ago to Eclipse Smart Home. And we continue, of course, to work with them. Recently, we have contributed some bindings above this base driver to connect the Smart Home abstraction layer. Okay, as a conclusion, I would say I want to say that oneM2M standard is a set of specifications that are very large, very flexible, addresses many aspects, and the drawback is that the M2M specifications, when you read it at first sight, are very complex. So here we were very glad that Eclipse oneM2M has already implemented part of that, and they were very good support as to integrate that into our system. The second lesson that was learned is that OSGI technology is really complementary. So we have showed how to integrate that with the vision, the architecture vision we have in the Home Gateway Initiative and in the OSGI Alliance. What we didn't make, but what could be maybe thought, is the way to use OSGI distributed OSGI specification to make this communication more transparent between the cloud and the box. So maybe that's a point of discussion. And then today, to have a full smart home SDK in open source or even commercially available, it sounds that there are several efforts still to be made, and that's a status that we make every time we do a prototype or a first product on this IoT smart home area. Thank you very much for your attention, and there are some minutes left for questions.
Thank you, Andre. So, are there any questions for Andre? We have a few minutes left. Go ahead.
So you mentioned that oneM2M is technology agnostic, and I know that, let's say, there are some parts in the oneM2M specification, like, you know, TR69 support, oneM2M support, and so on. So how much, let's say, overlap is there? I mean in a positive way, yeah, because you know, I think it's a good message to say, like, you know, you can use your OSGI in order to have oneM2M support, yeah. How much work is it to get there, yeah?
So if you mention oneM2M and TR69, we are in the device management area. So of course, in the device management area, oneM2M was clever to say that they don't want to overlap the work that has been done by the Broadband Forum and OMA. And then they make the link with those standards. Today, in the prototype, I didn't use oneM2M above the other specifications, and this is the way oneM2M wants to use TR69 and oneM2M. So in the slides, I showed that they are next to, close together, but next to each other. And in this way, we show that we could separate and we should in those systems, and that's a fact in the digital home today with the internet and TV communication, that we separate the communication path, so the commands that are really business related on a way, and this path is controlled by oneM2M, and the administration or the device management path is controlled by another by other protocols, and we can call TR69 in the smart home area. So I think this is separate, and of course we could maybe show something that is a facade with oneM2M that could use the TR69 model for devices management. I didn't make the things clear here.
Like, you know, I already have a set of specifications, yeah, that are also part of
Yeah,
oneM2M.
that's right.
And, you know, so how much further, you know, do we need to go in order to, you know...
Yeah, so there is, I think the facade is clear in oneM2M to use TR69, so I think that is the way to go in the specifications, but we didn't get it into this prototype.
So you say that you develop different base drivers.
Yep.
And I was surprised that, well, some of the basic ones were still missing. So will you provide them to the community, or are they only for all the talks? Are they very specific?
There is at least one base driver that we have contributed to the community, so we have the oneOcean base driver into the Eclipse Smart Home, and then this is, yeah, you know, it remains, there is some efforts left for us to publish other base drivers that are really solid and on which we could, yeah, put efforts to maintain that for the community. So we have not made this step towards the community, but yeah, that's a compromise that we have made. Hopefully, if we think about that, and maybe the Zigbee base driver will come from a collaboration with Telecom Italia here, but you know, they have already a base driver from Zigbee in their GEMA community.
Is open the box based on Eclipse Smart Home as abstraction, because you know there are some things items, or it's another different abstraction?
We could use Eclipse Smart Home above Open the Box, and we are today making that with first bindings above the base driver to show the way to go in Eclipse Smart Home. So this is a recent contribution, and we will communicate on that. But in the prototype, as I was very honest, and I didn't inserted a new abstraction layer. So here you see that we have used directly the base drivers, and we didn't implement an abstraction layer. But of course, your point is good. If we want to be to implement that in a proper way, an abstraction layer should be inserted here to simplify the work of application developers or the work of the one that implement a oneM2M connector towards all the devices that are discovered. So something is still a work in progress here.
Any more questions? Thank you all for coming.